Hello friends, I hope you all are fine. So let's start today's topic, and the topic which we are going to discuss over here is from the optical instrumentation, and it is the third topic from the optical instrumentation, and the name of the topic is laser. So in this video I'm going to give you the entire content from the laser, which is important for the GATE exam and even for your university exam. Okay, yeah, so first of all let's see the full form of laser. So the full form of laser is light amplification by stimulated emission of radiation. Here the word, this stimulated emission, is important. Like, this is not the spontaneous emission but the stimulated emission. Okay, yeah. So sometimes they may ask you in interview or in some kind of quiz or anything, like what is the full form of laser. Okay, as we all know from our childhood, laser we are much familiar with. So we used to play with the laser light in our childhood. Yeah, so let's have a scientific approach towards the laser, like how the working of laser and what are all the components, and yeah, what are all the important concepts related to the laser. Yeah, so here itself I have given definition. The laser is a device that emits light through a process of optical amplification based on the stimulated emission of photons. So here the important point is the optical amplification, and yeah, the stimulated emission of photons. So this is the definition of what the laser is. Okay. Yeah. So next I talk about principle of laser. So first one is absorption of energy. The next step is the spontaneous emission, and the last one is stimulated emission. As we all know, the stimulated emission is responsible for the lasing action. Okay, yeah. In upcoming duration of this video, you are going to see what the stimulated emission is and the clear conceptual understanding of all these three processes. Okay, so let's consider the two energy levels, which is first of E1 and next one is of E2. So when there is a transition between the higher energy state to the lower energy state, there is always an emission of energy, which is in the form of electromagnetic radiation. Okay, so here is the frequency of that electromagnetic radiation, and this H is nothing but Planck's constant. Okay, I think this is very basic equation like E equals to H nu, which you all are very familiar with. So here you can easily find the frequency of the radiation emitted by this particular transition. Okay, so first point, let's discuss about the absorption. So the atom in the ground state, you can say in the ground state may absorb a photon of appropriate energy and get raised to the excited state. So yeah, here you can see it is the ground state, and yeah, here is the atom which is in excited state. You can see over here this atom is in excited state. I have shown with the star mark over here. So this particular notation is for the excited state and just a simple notation for the ground state. So this photon is nothing but energy is absorbed by this atom and it has reached to the excited state. So this is the absorption phenomenon. So the next phenomena is spontaneous emission. As you can read over here, the emission of energy by an atom falling from the state of higher energy to the state of lower energy. As you can see over here, the higher energies, the atom which is having a higher energy is just falling to the lower energy. So it is releasing some energy. So this particular phenomena is known as spontaneous emission. The next one is the stimulated emission, or you can say it is the forced process. So when the excited atom is given with some photon of energy, it releases the atom and two photon. This additional two photon, they cause stimulated emission. Like, this emission is in forced form and it is also in controlled form, which is necessary for the lasing action. Okay, yeah. So here there is a difference in this equation itself. Like, the excited atom is given with some energy so that this atom will come into the ground state along with some electromagnetic radiation. So this radiation is what useful for us in the form of laser, and this radiation itself is having various qualities, like it is monochromatic, it's coherent, and it has high intensity and high directionality. All these points are very important for the laser, for the good laser. Okay, so the next important phenomena which is observed in the laser is the population inversion. So in case of the population inversion, this is more to the concentration of the atom in particular energy state, like the concentration of the atom N in particular energy state or energy level, you can say. Okay, So here is one equation, famous equation from the Maxwell-Boltzmann equation. Here n2 by n1 is equals to e raised to the power e2 minus e1 divided by kt. Okay, here this k is the Boltzmann constant, and yeah, this equation is equally valid. Yeah, so when the n1 is greater than n2, as you can see over here, like n1 is the number of atom in the ground state, and these two are the excited state 2. This is the excited state 3. Okay, and this is the population of the atoms in the ground state. This is the population of atom in the excited state 2. This is the population of atoms in excited state 3. So when there is n2 which is less than n1, like there are more number of atoms in n1, so the absorption of light dominates. Like when more number of atoms are present over here, they will absorb the light and go to the higher energy state. Okay, and when there is an n2 which is greater than n1, so in that case there will be stimulated emission. Like over here there are more number of atoms, so in that case they will try to come into the ground state by releasing this amount of energy, which is useful for the laser. Okay, so these 2 points are important when you talk about the population inversion for the laser. And yeah, this is also one of the basic principle of the lasing action. Like you can say there are four particular principles by which we can observe a lasing action. First one is absorption, second one is spontaneous absorption, emission. Next one is stimulated emission, and fourth one is population inversion. Okay, so these four phenomena constitutes the laser. Now, next point, let's discuss about the characteristic of laser beam. As you all know, the laser is having high directionality, high intensity, monochromatic, and coherent. Over here, I have given all the related terms. Like high directionality means there will be less angular and aerial spread. This angular and aerial spread, you can make these two concepts very clear in upcoming uh, uh, video. Okay, and the next is high intensity. As you all know, if there is a less angular or aerial spread, this intensity will be high. Monochromatic, yeah, it constitutes it composed of a single wavelength, and yeah, of one color only. Coherent means this coherence phenomena is just the phase relationship of the electromagnetic radiation. So there are two types, spatial and temporal coherence. I'll try to make you understand these points in the coming video. Okay, yeah, so the first point itself we are going to discuss is the directionality. Yeah, so for a good laser we required a less diversions. So this is the quality of uh, good laser. Like very less divergence is observed for the good laser, and these formulas are very important, and there are many questions seen from these two formulas in gate exam. So yeah, these formulas are important. The first one is the angular spread. So delta theta means the angular spread, which is equals to 1.22 into lambda divided by d. Here d is the diameter of this particular light source. You can say the aperture of this light source, or you can say aperture of the laser. And this is the surface area, this is the this is the angular spread delta theta. So by this formula itself, 1.22 lambda by d, you can calculate the angular spread. And the next point is of aerial spread. Aerial spread is nothing but pi r theta whole square. Okay, so this is the aerial, like you can say pi r square, and here this r is nothing but r into delta theta. Okay, this is equals to r. So when sometimes they ask the diameter of this particular spot, you can say this is the spot. So in that case, spot diameter equals to 2r delta theta. You can directly use this formula in case of calculating the spot diameter. As at the last I have given one question which is based on the spot diameter, you can just find it with the help of this particular formula. So these two formulas are very important for the gate exam. Okay, yeah, over here I have given like a low aerial and angular spread for efficient laser. Like if you want some laser to be very efficient, it must have a low aerial and angular spread. Okay, so the next point says intensity. As I have given you, the formula of intensity is power per unit area. So when there is a less aerial or angular spread, there will be more intensity observed for a laser. So yeah, for a good laser there must be a high intensity. Okay, yeah. The next point which we are going to discuss is of the monochromaticity. Highly monochromatic behavior is observed in laser. Okay, so highly monochromatic means single wavelength and of single color. Yeah, there is one quantity for the measurement, and this quantity is known as the degree of non-monochromaticity, which is denoted by the epsilon. So this is nothing but delta nu by nu. Here delta nu is the bandwidth, or you can say frequency band, and nu naught is the central frequency. So with this formula itself, you can calculate the degree of non-monochromaticity. You must remember that this is the degree of non-monochromaticity. So it is the vice versa of the monochromaticity. Okay. So epsilon must be low for a good laser. Yeah. We don't want our laser to be a non-monochromatic in nature. So epsilon must be small. Okay. Yeah. Here is one important formula which I want to discuss with you. So yeah, consider a large number of modes traveling into the laser cavity of length L. This is the length of laser cavity, and the difference in frequency between the consecutive mode is delta nu. Then uh, delta nu equals to C by 2L. So generally student asks why this is 2L. So let me explain. For example, if you consider this is the laser, so here is the reflecting material over here, and here is also reflecting material just by leaving this particular hole over here. So here the laser beam is coming out. So why this is 2L? So when you talk about L, so when the radiation is going from here, it reflects back from here and it will come in like this. So in this reflection, the distance traveled by this particular uh, radiation is 2 times the length. So whatever is the length of cavity, we just multiply it with the 2. So 2L over here for the lasing action. Yeah, that's why we have given over here the 2L. So this formula is very important, like delta nu equals to C by 12, where C is the velocity of light. This is 3 into 10 to the power 8 meter per second. So this formula is also important, and sometimes this lasing cavity is not of the air medium. It is with some medium with refractive index of mu. So in that case, you must use this particular formula, like delta nu equals to C by 2 mu L. Okay, these are the points to remember for this particular formula. And the next formula says number of modes, like how many modes can travel through this particular cavity, that is equals to the bandwidth divided by delta nu. So these are the parameters which will be given in the questions, and you have to find any one parameter which is unknown to you by using these formulas. Okay, so yeah, you can just use this formula or this notes, and you can remember it and you can directly solve the questions. Yeah. The next point says coherence, and yeah, high degree of coherence is required for the laser. If you want a good laser, it must have a high degree of coherence. So coherence is nothing but the measure of the phase correlation that exists in the radiation field of the light at different location and time. You have to observe the wave at different location and at the different time instant. Okay. First, we talk about the spatial coherence. If the two fields at two different points on the wavefront of electromagnetic wave has a constant phase difference over any time t, they possess the spatial coherence. Only just remember the definition from the coherence point of view, like what is the spatial coherence. So I have written over here, this particular is the definition of the spatial coherence. And for the temporal coherence, you must remember, like the temporal coherence refers to the correlation between the field at the point and the field at the same point at the later time. Okay. Yeah. In spatial coherence, you don't have any formulas, but in temporal coherence, you have formulas. So those formulas are really important. So coherence length equals to coherence time into the speed. You can just remember, like distance equals to speed into time. In that way, this formula is very easy for you. So coherence length is nothing but tau c into c. So here tau c is the coherence time and c is 3 into 10 to the power 8 meter per second, which we have considered the light as EM wave. Okay. Yeah, so let's discuss about the basic parts of laser and what are all the different type of laser. So the first one is the active material. So generally the cavity which we consider for the laser, so this particular cavity, whatever all the material present in this cavity, we can say it is the active material. So yeah, participate in the laser generating process. Yeah, so this particular laser generating process is for the active material is useful in laser generating process. Okay, so the next mechanism is the pumping mechanism. So that is very essential for the population inversion to happen. So we can say it is a optical pumping, we can have a chemical pumping, and there is an electric pumping, like by providing the battery voltage, or you can say, yeah, various other type of pumpings. Optical pumping means you can provide some flash or some arc. So in that way, the population inversion happens. And the chemical itself is like there is some chemical reaction. Okay, so there are various types of laser. So over here, I have given solid state laser, we have gas laser, and then we have semiconductor laser. In solid state laser, we have ruby laser and ND arc laser. Over here, this ND is neodymium. YAG is yttrium aluminum garnet. So this laser name itself is very popular. So ND arc laser. Here the ND3 plus ions are the major role for the lasing action. Over here, Cr3 plus ions are for the plays a major role in lasing action. Okay, so the output from these two laser is a pulsed output. Okay, this is the point you should remember. So the next one is the gas laser. Over here we have a helium neon laser, which is very popular. Here the neon plays a major role for the lasing action, and this is the atomic laser. You can say it is atomic laser, and the wavelength produced by this laser is 633 nanometer, and this is the continuous mode laser. Like the output which you will get is in continuous nature. Like this is the pulsed output, you can say. Yeah. The next important gas laser is the argon gas laser, and it is an ionic laser, and the argon ion is the main component for the lasing action. So in case of argon laser, you can have the output which is pulsed as well as constant. Okay, this CO2 laser is the molecular laser, and CO2 molecule is important factor for the lasing action. And yeah, this is also a constant and pulse output. You can observe both kind of output from this particular laser. And yeah, this laser has various applications, like in surgery you use, in welding application we use this CO2 laser. Okay, and this has the highest efficiency, which is of 45%. The efficiency of other lasers are comparatively less. So when you talk about the semiconductor laser, in semiconductor we have gallium arsenide laser, or generally you can call it as an LED laser. Okay, so they are continuous output they offer, and yeah, they are also having a wide application, generally for the signaling. Okay, yeah, so this is the overview of laser, and here are some questions which I have provided. So these are generally conceptual questions, and few of them are asked in previous year gate. So I request you to try out all the questions, and you can just form a table of answers, and you can post your answer along with the question numbers, like question numbers, and then you can post your answer along with the units. As you all know, units are very important while giving any answer. So with the units itself, you have to write your answer in the comment section, and if there is the discussion required for the answers of these questions, I will do that. You can just post in the comment section, and even if I receive a single comment, I will reply for sure, and I will make a explanatory video of all the questions out over here. And yeah, I'm here to explain each and every doubt of you all. Okay friends, I hope this video is very informative for you and useful for you as well. So thank you so much. Have a good day.